scale applications. They do a lot of things. Sometimes they do them well. Lots of code scaled out as easily as a square wheel rolls. They're normal. We all know what they are. We all know how they work. We're all accustomed to them. Sometimes we develop them. Sometimes we buy them. This talk is going to deal with monoliths, but not from the normal standpoint that most microservice talks deal with them. I am not interested in getting rid of your monoliths. Some of your companies, including the one I work for, paid good money for some monoliths, and they are not going to go away easily. So how do we deal with them? How do we make working with them suck less? Because that's really the best we can hope for in some cases, is to make our lives a little bit better as software engineers. I'm going to tell the story here in a little bit to try and lay some context for this. Hopefully some of you will identify with it. But just by show of hands, how many of you work for companies that your job, your company's mission is to build a piece of software? All right, so about half the room. So I'm assuming the rest of you work for companies like mine where software is not the core of your business. You probably work for a company that has an accounting system, a CRM, some piece of software that you pay good money for, and it is almost certainly a monolith unless you custom wrote it. Most businesses of a certain size are going to have at least one monolithic system. For the company I work for, it's a CRM. For a lot of companies, it's going to be an accounting system. We all have legacy code bases. We all have things that we deal with that are monoliths that are not going to die quickly or easily or ever. And so I want to kind of set some realistic expectations for what the subject of this talk is. We're not going to discuss how to move your monolithic application to a microservices architecture. There are lots of talks about that. There are whole websites, blog posts, all kinds of content devoted to that very subject. If you want to know how to move your application from a monolithic architecture to a microservices architecture, there's plenty of research material out there. Use Google, you're all nerds, find it. We're also not going to address specific implementation details. This is an architecture talk. Hopefully, most of you guys are used to thinking about design patterns, anti-patterns, thinking about things in an architectural way, thinking about things in abstractions rather than concretions. And so this talk is not going to talk about specific implementation details. That's going to be left up to you guys as mature software engineers, which I hope all of you either are or are aspiring to be, to figure out for yourself. That's an exercise for you in your environment. I am also not here to sell you a bill of goods. I'm not going to make you any fancy promises about what microservices will deliver for you, how they will cure cancer, or give unicorns, or cake, or cookies, or anything else. They will not allow you to use the force. They will not allow you to do anything unless you make them do it for you. They're just software like anything else. They will deliver exactly what you build them to deliver. What I want to present instead are options. As software developers, we need options. As we approach architectural problems, as we approach engineering problems, we need to have options. Options give us choice. Options give us the ability to make decisions based on trade-offs. And once we have options, then we can make, hopefully, good, better, best, or if we're not very good at our jobs, really bad decisions. What I want to talk about are some ways that my team in particular is planning to use microservices, some ways that we're already doing it, and some ways that we're hoping to do it in the future. But before we get into specific patterns, what about microservices? Microservices have a lot of hype around them. They are talked about quite frequently on the internet and at conferences like this. Sometimes they go under the name SOA. What the hell are microservices? As an exercise for this audience, anybody have a definition of microservices they'd like to put forward? Come on.
It's a portion, a small application specific for a larger application that handles part of that use cases services.
Okay. Does anybody have a competing definition? I'm shocked. Because nobody knows what the hell they are, really.
Breaking your application into separate resources and having an API associated with each resource so they can all talk to each other.
Yep. The reality is, microservices are fairly ill-defined. SOA has become less well-defined over the last few years, even though it's been around for quite a while. What I like to think of microservices as is they're like SOA, but with less Java and SOA. Glad somebody found that humorous. I thought it was just me. Now, the reason I say this is that SOA has been around for a while. SOA is something, there are multiple talks given on SOA yesterday, today. SOA has been around for a while. There are lots of enterprise-y solutions tied to SOA. Microsoft has Big Stock Services, which is a centerpiece for SOA architectures. Java has a whole bunch of stuff built around the concept of SOA. And the thing that I tend to use as a distinguishing characteristic between SOA and microservices is how central is an enterprise service bus to your architecture. With SOA, you almost always eventually boil down to having the centerpiece of your system being an enterprise service bus. If it's not an enterprise service bus, you might just call it RabbitMQ, ZeroMQ, whatever. You have some piece of messaging, some kind of messaging software at the heart of your system. That usually defines SOA. The hub of your system is some piece of interconnective software, something that allows all of your stuff to communicate with one another. Microservices do not have that as an assumption normally. Microservices can be thoroughly decoupled. They can talk independently, they can send events to each other, they can talk directly to each other, they can not talk to each other at all. Microservices tend to not have that central point of integration and contention as an assumption. But again, that's both a correct definition and completely wrong depending on who you talk to. Because we're talking about patterns, so nobody really knows what they're talking about. Everybody is just as dumb and just as smart as everybody else in the room when it comes to microservices. For some people, microservices are just SOA done right. For others, they're basically the same thing. Whatever. When you talk about microservices in your environment, with your engineering team, just come up with a definition that works for you. Be pragmatic about it. Because the reality is, if you go and work for another company, what they think microservices are, probably going to be completely different, at least in some form or fashion. So don't get too terribly dogmatic about it. We are, after all, software engineers, not religious zealots, myself excluded. But whether we call it SOA or microservices, what we want to get to are services. Independent units of computational capability, applications, whatever you want to call the packaging, these independent pieces of functionality that exist as part of a larger constellation of other services that work together or not, that can be composed or not, to help build a platform overall. And so there's a lot of variability in how you can build a microservice architecture, and we're not really going to talk about too much of that beyond here. Just want to give us kind of a broad, amorphous, not really a good working definition, because there's not really a good one to be had, in my opinion. And while most talks about microservices focus on using them to decompose, to break down monolithic applications, I'm much more interested in what other use cases they have. Because as we think about microservices, if their only use is to be able to replace monolithic systems, that's a fairly limited use case. Because not all monolithic systems need to be broken down that way. Some monolithic systems, maybe they're unicorns, maybe they're not, maybe there exists a healthy monolithic code base. Maybe there exists a monolithic code base that does not need to be broken down into individual pieces and scaled independently. Such things do exist. Most software starts out that way. Some software never grows beyond that. we should be willing to talk about microservices in other use cases and other contexts, and that's what I'm interested in. What are the other ways that we can use microservices other than as a way to get rid of monolithic systems and take one problem and turn it into many? Are there other ways that we can use microservices? And I think there are. And I think the solution to that is patterns. We have to talk about patterns. As developers, we're used to thinking about patterns. We think about design patterns, we think about anti-patterns, we think about these abstractions, ways of dealing with problems that have specific use cases, have specific trade-offs, advantages and disadvantages. We're used to thinking that way. And design patterns are not just for the nitty-gritty implementation details of our code, they also apply at the architectural level. We need design patterns, we need architectural design patterns, and microservices are one of them. Just like monoliths are an architectural design pattern. There is a time and a place and a good reason to use one approach versus another. But before we get into the specific patterns that I want to talk about, which there's 3 that I want to deal with today, I want to tell you a story. The company I work for is not a software company. We build software in order to run our business. Our core business at Nudge is selling education, asset protection, and other related products that are of interest to people who are real estate investors. We build software to facilitate that. We don't sell software. And so we have these different monolithic systems that we've built over the years to deal with the different pieces of our business. We have an event booking system, we have a customer support portal, we have an asset grading system that we develop, and we have numerous other systems that we put together, all these little monoliths throughout our organization. And all of them interact with another giant 800-pound gorilla of a monolith, which is Microsoft Dynamics CRM. Has anybody here worked with Microsoft Dynamics CRM? Oh, count yourselves blessed. It is an amazing piece of software that Microsoft did not write. They bought it and then continued development on it. It has a lot of great uses, but it's horrifying, especially as a Ruby developer, because it does not have a good API to work with, which is one of the patterns we'll talk about, is how to deal with that kind of thing. Dynamics CRM is mostly used by our marketing team, and eventually our sales data flows into it. The way that these systems interact right now is a mess. So, over the summer, we're embarking on a project as a team to do what so many developers dream of doing. We're going to burn the forest to the ground. We're going to completely re-implement Dynamics CRM. But we're keeping the software. We're still going to pay $100,000 for the software, but we're going to, instead of trying to migrate from 2011 to 2015, we're just going to say, nope, we're going to completely redesign how we use 2015 and figure out how to migrate the data over. It's going to be exciting. I dread some of the evenings I'm going to have dealing with this project. But we're going to make it happen, and we're going to probably kill ourselves in the process. But we're centralizing our business around this monolith. It's a reality. It's a business decision that we've made, a technical decision that we've made that makes sense for us. And sometimes the companies you work for are going to make those same decisions that, to a sane developer, are terrifying. The idea that they're going to invest tons of money in a monolithic system that is difficult for developers to work with. It's going to happen. Maybe it's already happening. And the question is, from my standpoint, how do we make working with this system better? How do we make working with Dynamics CRM not cause everybody on my team to want to quit or go work for Mastery Connect or whatever? That tip to you guys because you stole one of my favorite developers.
We'll steal the rest of them.
Well, actually, no, you won't, because I know there's at least one you won't take. So, now, Dynamics CRM can be extended via plugins and via other kinds of mechanisms, but it's not always fun. It's not always a good idea. but it can be done. There are ways to simply add on to this monolithic system and extend it indefinitely. Again, not always a great idea. But from our team standpoint, how do we not do that? How do we not just bolt more and more and more functionality onto this monolithic system? What are some ways that we can help mitigate the pain that this system causes us? And so that's where I want to start talking about these specific patterns that I think are available when using microservices in an environment where you can't get rid of your monoliths, or where you don't want to get rid of your monoliths, or where the accounting department, because they've spent hundreds of thousands of dollars on a piece of software, are telling you, no, you will never get rid of this monolith. How do we deal with that? How can we use microservices to make that better? The first pattern I want to talk about is microservices as proxies. You can substitute in the term adapter here, whatever term, floats your boat. The idea here, though, is that you have two monolithic systems that you need to integrate with one another. How do you get these two systems to talk to each other? In our specific scenario, it's our CRM and accounting, dynamic CRM and QuickBooks. Right now, we generate file exports. We have a customer service portal that our accounting department goes to. Why they go to the customer service portal to do this, I'm not entirely sure, but that's where they go. They have a list of export files they can ask for related to customers or invoices or shipments. They click a button, wait about 5 minutes, and then they get a CSV file that pops up and that they can download in order to then import that into QuickBooks. It's not great, but it works. It's kludgy, it's slow, but it works. And the reality is we could refactor this. We could, since we know we're using QuickBooks, we should use QuickBooks Web Connector and integrate it directly with CRM's API, one of the 3 or 4 that it provides, and we could get a slightly smoother transfer of data between the two of them. But then we're welding these systems together. It becomes very difficult to change either one of them. If accounting has a hard dependency on CRM, or CRM has a hard dependency on accounting, neither one of them can change easily. I think, again, just me thinking here, that microservices provide us some options here. And again, there are trade-offs, and I want to be completely honest about what the trade-offs are with taking this approach. Instead, what we could do is establish microservices that use CRM as a backing data store. So we're thinking of CRM here mostly as a database. And we have these services that talk to it via its approved APIs, and they expose data related to customers, invoices, and shipments. The 3 distinct pieces of data that we care about in the accounting world. And then we provide an explicit adapter, or we can use the API gateway pattern that is talked about on microservices.io, and we can then code a QuickBooks Web Connector or a file exporter against that. Now what this means is the accounting system can change, and everything on the left side doesn't have to necessarily. Now there's a trade-off here that anybody who's sharp should be able to pick up on. CRM, if it changes, necessitates changes across the entire stack of microservices. So there's a very obvious trade-off here. We have to make a decision which one of these monoliths in our environment is the least likely to change. For us as a business, CRM is the least likely to change. We're investing lots of money in it. We already hate QuickBooks, and so we are already talking about what we're going to replace QuickBooks with. So knowing that, having that additional context means we're going to make CRM this stable platform upon which we are then going to build up towards an integration with our accounting system. Depending on the assumptions in your environment, that decision is probably going to be different. If neither one of those systems are likely to change, this pattern actually makes a hell of a lot of sense. Just weld them together. If neither one is likely to change within the next 5 years, that's not wasted time to build that out. But if either one of those is likely to change, microservices can provide a good option for being able to have a slightly more flexible system. Now, one of the other things that this particular pattern buys us is that we now are talking about building a customer portal. We need to tell our customers what they bought with us, what we've shipped to them, all of this kind of information. Because we have these microservices now that are used by accounting, we can now reuse those to provide our customers a portal and visibility into all the stuff that they're doing with us. We're able to reuse those services without having to either get our customers using CRM, which would never happen because we're not going to get the licensing fees, or having to weld the customer portal onto the CRM API. We gain a level of abstraction that has some very real benefits for us as a company. But your monolith may vary. This may not be the right pattern for the type of business you have, for the type of monoliths that you have. So, what's another pattern? Microservices APIs. This is one that is borrowing and is really just a refinement of the API gateway pattern that is presented at microservices.io. Looking at Dynamic CRM, it provides an API that it recommends outside parties interact with, called OData. OData is a spec written by Microsoft that they don't even follow. It's amazing. I love how they wrote this spec, and then all the software that is supposed to use this spec and implement it doesn't implement it anywhere close to complete. I cannot get a count of all the customers in Dynamic CRM via OData. That sucks. It's horrible. I would have to pull the entire list of all 500,000 of our customers and count them in Ruby if I were to do that. That's horrifying. I should just be able to add the little count query onto the end of the OData request and get it, but I can't. Yep.
I once contacted one of the OData maintainers about a feature, whether it existed in version 1 of the spec, and he couldn't figure it out.
Yeah. Yeah, and of course, what was it? OData is plowing along. They have version 1, version 2, version 3, and I think version 4 is currently with Oasis getting standardized. And yet I think CRM 2015, which just came out a couple of months ago, is still implementing version 1 of the spec, despite the fact that version 3 has been around since 2013. No idea why. So, needless to say, CRM, in particular, has a horrible API, unless you're a .NET developer. Then you can use WCF, and everything is, well, whatever the C# equivalent of unicorns and rainbows is. So this is the way that you would normally build an API onto a monolith. Whether it's one you built or one you bought, it would normally provide that for you, or you would build it on. Big enterprise systems like Dynamic CRM have an API. They actually have multiple. They have OData. They have WCF, which is really just soap with poop-flavored sprinkles on top. They have, their filtered views, which is SQL, but with security that doesn't always make sense. And so, yeah, it's amazing to work with if you're not a .NET developer. Just makes you want to kill somebody, particularly a Microsoft developer. But, there's another way to deal with this. We know that if you have a monolith that you know has a bad API, so you have a known bad actor in your system, how do you deal with it? Abstract it. Deal with the bad actor and isolate its bad behavior. Just like we looked at before, you can have independent services. Those can speak .NET. They can use the SDK. They can talk to CRM the way it really clearly wants to be talked to. And then they can expose a JSON API, a sane SOAP interface, if such a thing exists, or whatever else you want. Heck, they can spit out JPEGs if that's what you want your API to be. The fact is, those take over the responsibility of actually talking to that monolith in the way it prefers to be talked to. And then you can abstract all of your other systems from having to deal with that. You can clean up somebody else's mess using microservices. Again, this is something where, unless you have this particular need, unless you have a known bad actor, like dynamic CRM and the fact that Microsoft has not implemented the OData spec properly in their own bloody software, this is probably not an approach for you to take. But it might be. It's a good option. It gives you something that you can do when you have a system that you're not entirely comfortable working with. Finally, microservices as experiments, and this is my favorite one. This is my favorite one because it's one of the ones that we've actually implemented and have implemented fairly well in our current environment. This one deals with the question of what happens when you have a feature and you don't know where it's supposed to go. So for us, we have a survey system. Every time we have a customer interaction, we collect survey information from them. Did you like how we talked to you? Did the person on the other end sound friendly? Whatever. We have all these questions that we ask every time we sell somebody something or have a customer service incident. We have all these different times that we have these surveys go out. And we don't know where this behavior needs to go. We think it needs to go into dynamic CRM. We think we want to track that data there, but we're not sure yet. Now, if we were building a monolithic system, whether it's CRM or a system you built, and you have this new feature request, well, we'll just add it to the pile of code we already have. That's the normal way to go. We could build a plugin for CRM, do all this survey stuff. Heck, we could buy one off the shelf in all likelihood, and just bolt it in, leave it alone, and go along our way. But the problem is, like in our scenario, we don't even know what the data model looks like yet. We're not even sure about it. We think we understand it, but we don't know all the things that a survey is related to. We don't know all the details that we need to collect at the time that a survey is submitted. We're not entirely sure that we're storing the question and answer stuff in the most efficient way. We've got a lot of questions. And so instead, what we did is we built surveys as an independent application. It is a microservice because it does only one thing. It touches customers and events. What was it? All basically by verifying that whenever a survey request comes in, which is just a URL, that it's for a valid customer and a valid event. Based on that, we then present them with a particular survey. They fill it out, and we have a database for the surveys service that, stores all this data. We're using Rails for this, which means we can change the schema without too much hassle. We can do experimentation on this and figure out what the best way to deal with this data is. We're able to experiment and discover the right way to do this without having to invest a lot of time in building a CRM plugin or figuring out how to interface with a third-party service, if we want to use Wufoo or whatever for this. We're able to do some discovery and get some more knowledge about our particular problem domain and basically delay making a decision that we might regret. And so we think, and again, we still don't know for sure because we're still figuring this out. This system's been in production for about 4 months now. We think eventually we're going to pull surveys into CRM where we'll actually just use CRM as the backing data store for it. The surveys, all the question responses, they'll all get stored there. We'll be able to run reports on it there. That's where we think it's going to go. By doing things the way we did on the left here, we can make that move fairly easily. If our assumptions are wrong, if we discover something that says, no, this doesn't belong in CRM, we can just leave it the way it is and let it keep on running. We're not forced to make any decision before we know what the best choice is. And that's a big thing I think can come from using microservices, not to get rid of our monoliths, but to help figure out what belongs perhaps in which monolith that you have. So if you've got multiple big applications in your business and you don't know where some behavior belongs, figure it out. Don't make assumptions and make potentially bad decisions. Spend a little bit more time, discover the right answer, or discover at least a better answer, and make decisions based on an informed perspective on the environment. Now, this is kind of the last thing I have here to talk about in terms of patterns for microservices. And so I just want to conclude with a few final remarks here. The big thing for me is that there are uses for microservices other than getting rid of your monolithic application. This is an area where I think as software engineers, we're not really talking about things enough. We're assuming that this is what you use microservices for, and we're ignoring all the other possible use cases. I think that's a problem for us as a community. Just like all design patterns, and especially architectural ones, we need to examine trade-offs. We need to figure out what the right answer is. And I think as a community, this is something that we need to spend some more time doing. Microservices have some uses outside of what we think they're good for. They're certainly good for getting rid of monolithic applications. But what about the scenario where you can't? I think there's still some use cases here in which microservices can serve monoliths and can actually do some good for engineers and for companies. But I want to be completely honest, there is no right answer for every circumstance, or no singular right answer for every circumstance. There's always trade-offs. As engineers, we have to figure out what those trade-offs are and help the businesses we work for make better decisions. They understand the business side, we understand the technical side. We probably should understand the business side a bit better than we tend to. But we need to help not just make good technical decisions, but also help our business make good business decisions that are backed by tech. Now, the 3 patterns that I mentioned are just a starting point. They're actually borrowing heavily from patterns that are already out there, that have already been discussed from microservices.io and other places. I think there are more. I think there are other ways that we can make use of microservices that do not fall into the, I just want to get rid of this crappy code base that I hate working with anymore. I think there are other options available to us, and I think we need to discover those as a community and as individual developers in our context. And so, with that, are there any questions? Comments, welcome, concerns, criticisms? Keep any vegetables to yourself. Okay, ran a bit short here. I don't think anybody will complain about that. That gives you more time to talk to the people you actually care about here and get to your next presentation well ahead of time and find a nice comfy seat. For those of you who are sitting on the perimeter, I'm sure you'll prefer that the next place you end up at. So, again, you can find me online at Plain Programmer. Go to Joined In. Let me know what you thought.